In exercise number 5, we're asked to find theta given the following information. We're told that the cosine of theta is equal to the square root of 3 over 2. So let's draw out a picture of what that would look like. So I'm going to draw our angle. So here's our coordinate system. There's our unit circle. And I want an angle such that its cosine value is square root of 3 over 2. So let's just draw an arbitrary angle in. So cosine, notice here that this value is positive. And we know that cosine measures left-right, so cosine is positive in quadrants 1 and quadrants 4, which means that there's an angle out there whose terminal side has an intersection with the unit circle with an x value of root 3 over 2. Additionally, there's going to be another angle out there. I'm going to draw it in purple here. You can think about it like a reflection of the first. So this angle, okay, and this angle both have the same cosine value. This also comes over to the right by root 3 over 2. So let's do the yellow one first. We know by looking at our unit circle, okay, that the angle corresponding to a cosine value of square root of 3 over 2 is a small angle, and it's 30 degrees. So now what we need to do is add revolutions to that. So here's the first angle, but also if I wrap around 360 degrees from that point, I'll end up back there again. So what I want to do is start adding multiples of 360 degrees. Now you have to label what k is. I have to say that k is an integer. If I'm going to use k over here, I have to define it over on the right side. So that's one solution. So for example, this gives me the following set of angles. This tells me that 30 degrees is an answer to this problem, that 390 degrees is an answer. By the way, this is when k is equal to 1. Notice that if I plug that in, I'd have 30 degrees plus 360 times 1, which is 30 degrees plus 360, which is 390 degrees. That's where I got this 390 from. We could do another revolution, and another revolution. We could also do negative values for k as well. Basically, we're finding all of the angles that are coterminal with that 30 degree angle. So this is one of the answers. The second answer, second set of solutions here, if this was positive 30, then we could either write this as negative 30 or 330 degrees, because they're both the same. They're both going to give us the same values. So we have 330 degrees would take us from here all the way over to there. And that's going to give us the same value as that theta. So it's irrelevant which way we think about the rotation. So 330 degrees plus, now we need to start adding revolutions again. So take a revolution, multiply it by an integer value. And this gives us another set of solutions. If you want to write those in terms of radians, the first one, 30 degrees again is pi over 6 plus 2k pi. That gives us our first set of answers, and the second set of answers would be 330 degrees. Okay, so let's go ahead and convert that. If you think about that, that's really 2 pi minus pi over 6, which is going to be 12 pi over 6 minus pi over 6, which is 11 pi's over 6. Again, we should say for this where k is an integer.